Are you guys able to view the screen?
Yes, ma'am.
So we have seen what is LTI system, right? So what is impulse response? So if we give our input x of n to any system, to any LTI system, it undergoes transformation and we get output y of n, right? So we say that y of n is nothing but the transformation on x of n, right? So if we give x of n to the system, we get y of n, where output is y of n output is transformation of input signal. So if you give delta n to the system, similarly you will get impulse response, right? If you give impulse signal to the LTI system, you get impulse response. Response to that impulse signal, that is impulse response. It's the same for continuous also. If you give delta t impulse signal, you will get h of t, which is the impulse response. So that is about the impulse response. So today's class we'll see what is step response. Okay. Suppose if you are giving delta n to the system, to the LTI system, you get h of n. What if you give u of n? If you give unit step to the system, if your signal is unit step, then your output will be step response represented as S of n. Got it, everyone? Is it clear? If you are giving unit step signal as an input to the LTI system, you get step response. Response to that unit step signal, it is called as step response. Got it, everyone? What is step response?
Yes, ma'am.
So if you're, so we know y of n is equal to x of n convolved with h of n, or using commutative law we can also write y of n is equal to h of n convolved with x of n. So using commutative property we can write like this, right? We can interchange the inputs using commutative law. So your output, if output y of n becomes s of n, when your input x of n will become u of n. Okay, it's h of n convolved with u of n. Got it? Is it clear? So when you're giving unit step signal as an input to the system, you get output as s of n, which is the step response. This is unit step signal input and your output is step response. So we shall see the relationship between step response and impulse response. Okay, so we'll try to get the relationship between S of n. What is the equation for S of n? Okay, this is the relationship between S of n and h of n. Okay, so we know that output is nothing but x of n convolution h of n. Input signal convolved with the impulse response give you the convolution sum or y of n, right? I can interchange this. I can write h of n convolved with x of n using commutative law. So when your output y of n becomes the input, when will your output become y of n becomes step response? When your input becomes unit step signal, x of n becomes u of n, that time y of n will become step response. Okay, today's topic is step response. We'll try to get the equation for this step response in terms of discrete time as well as continuous time signals. Okay, so in terms of convolution sum, S of n is equal to h of n convolved with u of n. So what do you get the equation of convolution sum? S of n will be equal to, what is the equation of convolution sum? Summation k is equal to minus infinity to infinity h of k into u of n minus k. This is the equation of convolution sum, yes or no?
Yes, ma'am.
Yes, ma'am.
So u of n minus k, from where to where will the signal exist? U of n is a signal which exists from 0 up to infinity with an amplitude 1, right? U of n. So we are replacing n with k. So u of k is also same. U of k is a signal which exists from 0 to infinity with an amplitude 1. right? So u of n minus k means from where to where will the signal exist? Here our x-axis is k. Always in convolution sum, always your x-axis will be k. Remember that. This is just for your reference. We are replacing u of n with k, that is u of k, because our x-axis is k. So you check u of n minus k from where to where it will exist.
Minus infinity to n, ma'am.
It will exist from minus infinity to n, right? So you have to plot u of k plus n, then take time reversal, you will get u of n minus k. So this will exist from minus infinity up to some value n. We don't know that value, okay? This is u of n minus k. So can I write that definition of u of n minus k as u of n minus k is equal to 1 if n minus k is greater than or equal to 0, or I can also write k less than or equal to n. Okay, so u of n minus k is equal to 0 when your n minus k is less than 0 or k is greater than n. Can we write the definition of u of n minus k like this? It is equal to 1, amplitude 1, when n minus k is greater than 0. Okay, if n minus k is greater than or equal to 0, then it is 1. Or you can tell if k is less than or equal to n, then you can tell, yeah, k is less than or equal to n, you can tell that u of n minus k is 1. It is 0 if n minus k is less than 0, or if k is greater than n, it is equal to 0. The signal amplitude is equal to 0. This is the definition of u of n minus k. According to this definition, can we write the equation like this? So u of n minus k amplitude is 1. So your S of n step response will be equal to summation k is equal to minus infinity to n h of k into 1. Why the limits have become minus infinity to n? Because it's existing from minus infinity to n, u of n minus k. So this u of n minus k is 1 if n minus k is greater than or equal to 0, or if k is less than or equal to n. So what happens is, it will, so our upper limit will become n. Okay, got it? Upper limit of summation will be n. Clear everyone? Lower limit remains the same, minus infinity. Upper limit is n. Got it?
Yes, ma'am.
So step response, what is step response? It is a summation of impulse responses from k is equal to minus infinity up to some particular sample n. Got it? What is S of n? This is the equation for S of n or step response. It is equal to summation k is equal to minus infinity to n h of k. This is the equation of step response for discrete time signals. Okay, let us see for continuous time signals what is the equation for step response. It is similar to this. Okay, so for continuous time signals, as we have seen, y of t is equal to h of t convolved with x of t. Okay, if you're having x of n and if you're having h of t as the impulse response of this system, you get output. Sorry, if you're giving x of t as input to the system, LTI system having impulse response h of t, then y of t will be the convolution of x of t convolved with h of t. Okay, using commutative law, I can also write it as h of t convolved with x of t, as I have written here. Okay, this is for continuous time signals. So what is step response? Step response S of t will be, you'll be getting when your x of t is replaced with unit step u of t. Okay, so if you're giving unit step signal to the LTI system having impulse response h of t, then you will get S of t, where S of t is your step response. U of t is unit step. So basically, what is step response? It is output of the system when input is equal to unit step. Got it, everyone? Y of t, this y of t becomes S of t when x of t is equal to u of t. Got it? Is it clear?
Yes, ma'am.
So in terms of convolution integral, how do we write this? This is S of t. Okay. How do we write it in terms of convolution integral? We write it S of t is equal to integral minus infinity to infinity h of tau into u of t minus tau into d tau. Yes or no? This is the equation for step response, right? Sorry, this is equation of step response in terms of this convolution integral. Okay, now we'll try to evaluate this u of t minus tau. Okay, so u of t minus tau is equal to 1 if t minus tau is greater than or equal to 0, or you can tell tau less than or equal to t. Okay, this it will be equal to 0 when t minus tau is less than 0 or if tau is greater than t. Okay, how do you plot u of t minus tau? From where to where will it exist? U of tau is unit step, which is equal to u of t. Okay, here your x-axis is tau. It's existing from 0 till infinity with an amplitude 1. What about u of t minus tau? You do tau plus t, then t minus tau. Or t plus tau, then t minus tau.
Minus infinity to tau.
It will be existing from minus infinity to tau, right? U of
Ma'am,
t
t
minus
right, ma'am.
tau. Yes?
Minus infinity to t, right, ma'am?
T, sorry. It will be existing, so x-axis will be tau. So it will be existing from minus infinity to t. Got it, everyone? Just a minute. It is t or tau? So u of t minus tau is equal to 1 when t minus tau is greater than or equal to 0 or tau is less than or equal to t. So what is the meaning of this? So it will exist till t, okay? So minus infinity to t. So now you can take the limits. So u of t minus tau is 1 if t minus tau is greater than or equal to 0, okay? Or you can also take tau if tau is less than or equal to t, it is equal to 1. Okay, it is 0 if t minus tau is less than 0 or if tau is greater than t. So the signal will exist from minus infinity to t because t is a constant, okay, like our n. So now the restriction for upper limit will be till t, right? So s of t would be equal to integral minus infinity to t h of tau into 1 into d tau. So the equation for step response in terms of continuous time signals is s of t is equal to minus infinity to t h of tau into d tau. Got it, everyone? Clear? Is it clear, everyone?
Yes, ma'am.
So this is the equation for step response for continuous time signals. And for discrete time, you have S of n is equal to summation k is equal to minus infinity to n h of k. This is the equation for discrete time signal. This is the equation for step response. So usually how they'll ask you problems is, so you'll be given with impulse response, h of tau or h of k, but you have h, that is h of n or h of t they'll give you, and you have to find the step response of the continuous time or discrete time systems. Got it? Is it clear, everyone? Equation of step response clear? How do we got this equation?
Yes, ma'am.
So step response is the output of the system when your input is equal to unit step signal, u of t or u of n. Suppose you are giving u of n to the system with impulse response h of n, then you get s of n. Okay, where s of n is nothing but u of n convolved with h of n or h of n convolved with u of n. As we have seen, this is with respect to discrete time signals. With respect to continuous time signals, if your input if your input x of t is equal to unit step for a system with impulse response h of t, then your output will be s of t, where s of t is u of t convolved with h of t or h of t convolved with u of t. Clear, everyone? Is it clear? Shall we solve some problems on this? This is the equation. Okay, so s of t is equal to integral minus infinity to t. This is tau is equal to minus infinity to t, h of tau into d tau for continuous time signals. And for discrete time signals, you have s of n is equal to summation k is equal to minus infinity to n h of k. Clear, everyone? Step response equation for continuous time and discrete time signals. Is it clear, guys?
Yes, ma'am.
Shall
Yes,
we
ma'am.
solve some problems on this? So take down the problem. H of n is equal to half to the power of n into u of n. So this is the given impulse response. So you have to find the step response. Find s of n or the step response of the system. So what is the equation for s of n? What is the equation for s of n? We have seen now what is the equation of s of n? Step response equation. If k is equal to minus infinity to n h of k. Got it? Upper limit is n here, not infinity. That is the change here. Got it?
Yes, ma'am.
So now you have got u of n. So u of n starts from 0 and it will go up to infinity. So what happens to our limits? This one. So how do we try to evaluate this? You have h of n is equal to half to the power of n into u of n. That means the signal will start from 0 and it will go up to infinity. Okay. So since u of n starts from 0, your lower limit will be equal to 0. Okay. So if n is less than 0, what is your step response s of n?
0, ma'am.
You will get 0 if n is less than 0, because unit step starts from 0 and it will go up to infinity. So if n is less than 0, your step response s of n is equal to 0. This is case 1. Coming to case 2, if n is greater than or equal to 0, what is your s of n? S of n is equal to summation limits k is equal to 0 to infinity h of k. What is your h of k? Which is your h of n. Replace n here with k. Okay. So you have summation k is equal to 0 to infinity half to the power of k. Summation k is equal to 0 to infinity half to the power of k and to u of n. U of k. U of k is a unit step signal. So it will start from 0 and it will go up to infinity with an amplitude 1. Amplitude is 1 for this. So you can take substitute as 1. Now try to solve this. Sorry, 1 minute. It is not k is equal to 0 to infinity. K is equal to 0 to n. K is equal to 0 to n. I am sorry. Yeah. Now which form is this? step response equation is k is equal to minus infinity to n h of k. Since we have unit step here, unit step will start from 0 and it will go up to infinity. So lower limit will become 0. That's all. Okay, no, don't put upper limit as infinity, because step response will exist from summation k is equal to minus infinity to n h of k. So it's a summation from 0 to n, not 0 to infinity. Okay, keep that in mind. So lower limit will become 0. Upper limit will be n only. Now try solving this. What form is this?
1 by 1 minus alpha.
No, n is equal to 0 to n it is, not 0 to infinity. Summation n is equal to 0 to n, alpha to the power of n is, what is the equation? We have used this equation in previous problems.
1 minus alpha power n plus 1 by 1 minus alpha.
Yeah, it's 1 minus alpha to the power of n plus 1 by 1 minus alpha. So your alpha is half here. So 1 minus half to the power of n plus 1 divided by 1 minus half. So you can keep it as it is, or you can solve it further. If you solve it further, what do you get? So S of n is equal to, denominator part I will solve it, you get 2, right? 2 into 1 minus half to the power of n plus 1 for n greater than or equal to 0. Clear, everyone? Is it clear? This is of this form. Okay, don't confuse it with other one. Summation, you have different formula. N is equal to 0 to infinity, alpha to the power of n is 1 by 1 minus alpha. That is different. Don't get confused. You have n is equal to 0 to n, alpha to the power of n is 1 by 1 minus alpha to the power of n plus 1 by 1 minus alpha. Got it? Clear, everyone?
Yes, ma'am.
So, did you understand this problem, everyone? You have any doubts?
Ma'am, but here half to the power k is there.
How you got k? Because it's h of k, right? Because you have h of k, we are replacing n with k here. Okay, this n will not matter. This we can take it as k here, because summation is on k. Here it's on n. Okay. Clear? Clear, everyone?
Ma'am, then it is half to the power k plus 1, no, ma'am?
No. Wait. This is n plus 1, capital N plus 1. Got it? Clear?
Okay.
Is it clear? See, this is summation n is equal to 0 to capital N, small n is equal to 0 to capital N, alpha to the power of n is equal to 1 minus alpha to the power of n plus 1, capital N plus 1 by 1 minus alpha. So this would be n plus 1 only. Clear?
Yes, ma'am.
Okay. Did you follow this problem, guys? So you have been given h of n, that is impulse response. You have to find step response. What is step response? Step response is output of the system when the input is unit step. Okay. So S of n is summation k is equal to minus infinity to n h of k. So because you have unit step here u of n in this impulse response, so lower limit will be from 0 to n. Okay. So if n is less than 0, step response will be equal to 0. If n is greater than or equal to 0, step response would be equal to summation k is equal to 0 to n h of k. So h of k is nothing but h of n. You are replacing n with k. You have half to the power of k into u of k. U of k amplitude is 1, so put 1. So summation k is equal to 0 to n half to the power of k you have. So this is of this form. Summation n is equal to 0 to n, alpha to the power of n is 1 minus alpha to the power of n plus 1 by 1 minus alpha. So S of n would be, your alpha is half, 1 minus half to the power of n plus 1 by 1 minus half. You can put it like, you can keep it like this only, or you can simplify this denominator and put, you can write like this also. Clear, everyone? Got it? Is it clear? Shall we move on to next problem?
Yes, ma'am.
So take down next problem. H of t is equal to t into u of t. So h of t is equal to t into u of t. Since you have u of t, so it will exist from 0 to t. Okay, the limits of integration would be from 0 to t. So s of t is equal to integration tau is equal to minus infinity to t h of tau into d tau. This is our equation for step response for continuous time signals. Okay, you have integration limits from minus infinity to t h of tau into d tau. So first case, when t is less than 0, what is the step response if t is less than 0? They are giving you it is t into u of t. U of t will exist from 0 to infinity with an amplitude 1, right? So the summation, so this integration limits would be from 0 to t. Okay. So if t is less than 0, what happens?
0.
S of t will be equal to 0. If t is greater than or equal to 0, what is s of t? S of t would be integration 0 to t h of tau into d tau. So what is h of t? We are replacing t with tau. Okay. So we have 0 to t. H of tau is t into u of tau. So t will be equal to tau into 1 into d tau. So what do you get? So if you integrate with respect tau with respect to d tau, you get tau square by 2 with limit 0 to t. So that would be t square by 2, right? Half into t square minus 0. So you get t square by 2. Got it, everyone? Clear? So you can take, right, s of t is equal to 0 if t is less than 0. It is equal to t square by 2 when t is greater than or equal to 0. Got it? It is clear, guys?
Yes, ma'am.
Everyone, it is clear? Clear or not?
Yes, ma'am.
Okay. So take down next problem. H of t is equal to e power minus mod t. So what is h of t? If h of t is e power minus mod t, what is h of t?
E power t for t less than 0 and e power minus t for t greater than 0, ma'am.
Yeah, e power t for t less than 0. Y means you have e power minus of minus t, it will become e power t for t less than 0 values. Okay, for t greater than 0, it will be e power minus of plus t, which will be equal to e power minus t. Okay, so it's e power t for t less than 0, e power minus t for t greater than or equal to 0. Okay, so these are the two conditions for t values, t less than 0, t greater than or equal to 0. Now try to solve the step response. S of
Ma'am,
t
is
is
it
equal
modulus
to,
or brackets, ma'am?
yes,
Ma'am, e to the power minus modulus or bracket, ma'am?
this is mod here.
Ma'am,
Mod.
then mod minus is nothing but plus, no, ma'am.
No, for negative values, you have to take e power t. For positive values, you have to take e power t.
Ma'am, but modulus is only for t, no, ma'am. Then
Wait, if you want to understand this, how we got e power t, e power minus t, So if e power minus of minus t, if you put, it will be e power t. That is for t less than 0. So if you put plus t for t greater than or equal to 0, you get e power minus of t. It will be e power minus t.
No,
So
in
h
place,
of t, if we give
put,
like this, it means for t less than 0 and t greater than or equal to 0, we write an equation like this. E power minus mod t. That means for t less than 0, it is e power t. For t greater than or equal to 0, it is e power minus t. Got it? That we represent it like e power minus mod t. For t less than 0, it is e power t. For t greater than or equal to 0, it will be e power minus t. Got it? We represent this like this. This is equal to this. Don't try to derive from this. This we represent like this. Got it? Clear? So now try to solve the step response. S of t is minus infinity to t h of tau into d tau. So case 1, if t is less than 0, what is S of t? If t is less than 0, what do you get? S of t.
1, ma'am.
Why 1? You have integral minus infinity to t. If t is less than 0, minus infinity to t, e power tau d tau. Because it's e power t for t less than 0, right? Substitute this here. In place of h of t, put h of tau, that is e power tau d tau. Try solving this. What do you get? You get e power t, right? Is the step response equal to e power t? First case, if t less than 0.
And limits
Upper
is
limit minus lower
infinity
limit.
to 0.
Yes, any doubt?
Limits is from minus infinity to 0 for t less than 0.
T is less than 0. We don't know what is that t. It is less than 0, some negative value. That is t. So the limits would be minus infinity to t itself. Got it? We don't know what is the value of t. So we have put t only there. Got it? But t is less than 0. It is equal to some negative value. Got it?
Yes, ma'am.
This is for t less than 0. For t greater than or equal to 0, right? For t greater than or equal to 0, what is S of t? So how will our h of t look? It will be a decreasing exponential. For t greater than 0, it will be e power minus t. For negative values of t, it will be increasing exponential, right? It will be e power t. So for t greater than or equal to 0, we are taking. Okay, we don't know what is t here. So what is S of t? So t might be somewhere here, greater than or equal to 0. Okay. So how will you take the limits of integration? So you have minus infinity to t, h of tau into d tau. T is some positive here, greater than or equal to 0, some positive value of t. Okay, so that time you'll have S of t is equal to integral minus infinity to 0 e power tau into d tau plus 0 to t might be some value which is greater than or equal to 0. Okay, 0 to t e power minus tau into d tau. Because for positive values, t greater than or equal to 0, it's e power minus t. So I have substituted e power minus tau into d tau. Clear, everyone? It is clear? It will have both positive values and negative values. Okay. So for t less than 0, it is e power t. For t greater than 0, greater than or equal to 0, you will have like this. Clear? So try to solve this. Did you guys follow this? So try solving this.
E power minus t.
Check once what you get. S of t is equal to e power tau into d tau. So that would be equal to e power tau by 1. So we e power tau with limits minus infinity to 0. Plus we have e power minus tau by minus 1 with limits 0 to t. Right? Now substitute upper limit and lower limit and check what you get. S of t.
Ma'am, in second case, we
Here,
are considering both, no, ma'am.
yes. Second case, you have to take both. Because t greater than or equal to 0, t is here. So it's from minus infinity to t, right? Minus infinity to t means minus infinity to 0 plus 0 to t. So upper limit would be e power 0 minus e power minus infinity plus, we have minus 1, I will take minus only here, minus e power minus t minus e power minus 0. So e power 0 is 1, e power minus 0 is 1, e power minus infinity is 0. So you have s of t is equal to 1 minus 0 minus e power minus t minus 1. So what do you get? 1 minus e power minus t plus 1. So that would be 2 minus e power minus t. Got it, everyone?
Yes, ma'am.
Clear? Is it clear, everyone? Are you guys solving?
Yes, ma'am.
Okay, so try to understand the given problem. I'll brief up once. So you have been given h of t is equal to e power minus mod t. So that is equal to e power t when t is less than 0. It is equal to e power minus t when t is greater than or equal to 0. Okay, so our step response for continuous time signals is integral minus infinity to t, h of tau into d tau. So if t is less than 0, we don't know what is t. It might be some negative value, minus 2, minus 3, anything. So s of t is integral minus infinity to t e power tau into d tau. Because for negative values, we take e power t, e power tau into d tau. So if you substitute upper limit and lower limit, you get e power t. So second case, if t is greater than or equal to 0, so t might be somewhere here, greater than or equal to 0, greater than 0, okay, it's somewhere it is here. So the limits of integration would be from minus infinity to t, h of tau into d tau. So from minus infinity to 0, it is e power t or e power tau into d tau, plus from 0 to t, it is e power minus tau into d tau, okay. So integrate this with respect to tau. You get e power tau with limits minus infinity to 0 plus e power minus tau by minus 1 from 0 to t. Okay, upper limit minus lower limit you do, you get 2 minus e power minus t. Clear, everyone? Got it? It's clear?
Yes, ma'am.
Did you all follow?
Yes, ma'am.
Take down next problem. Find the step response of the system whose impulse response is given as h of n is equal to delta n plus delta n minus 1. You have to find s of n, that is step response. So h of n is equal to delta n plus delta n minus 1. So it is h of n is equal to, how do you represent this? It is equal to 1 comma 1. Your origin is at n is equal to 0. Got it? Clear? This is at 0 and this is at 1. This is your h of n. Okay, it is equal to delta n. Delta n means it is an impulse at n is equal to 0 plus delta n minus 1. So at n is equal to 1, it is equal to 1 amplitude. So this is your h of n. You have to find s of n. S of n is equal to summation k is equal to minus infinity to n h of k. So at n less than 0, what is the value of s of n? At n less than 0, what is s of n? We don't have any value here, right? What is s of n? It is equal to 0. So if n is equal to 0, what is s of n? It is equal to 1. Right? Are you guys following? For n greater than or equal to 0, what is s of n? It is equal to 1 plus 1, which is equal to 2, right? So that is all this problem. S of n is equal to 0 when n is less than 0. It is equal to 1 when n is equal to 0. It is equal to 2 for n greater than or equal to 0. Got it, everyone? Clear?
Ma'am, so 3 cases should we write, ma'am?
Yes, n greater than or equal to 1 you can take. So only our h of n is existing only for these two values, 0 and 1. So for n less than 0, it is 0. Summation of impulse it is, right? So n is equal to 0, you have only one impulse, that amplitude is 1. For n greater than or equal to 1, at n greater than or equal to 1, you have 0 at 0 and 1 also. So 1 plus 1, it is 2. Got it, everyone? Clear?
Hello, ma'am.
Yes.
If we use that formula, we will get summation of delta of n is u of n, no, ma'am.
Summation of k is equal to 0 to 1 you will get.
Yes, ma'am. Can you do like that, ma'am, using the formula, ma'am?
It is the same you will get using formula also, right?
No, ma'am. I'm
So,
getting u of n plus.
summation. So from 0 to 1 you will get 2 here, that's all. What is h of k? It is 2. 2 samples you have with amplitude 1, so it is 2. It's the same, no, both. Just you have taken one extra case for n less than 0 and n is equal to 0. So if n is greater than or equal to 1, so it will be k is equal to 0 to 1 or minus infinity to 1. So you'll have only 2 samples, right? That's all.
Okay, ma'am.
Okay. So take down next problem. H of t is equal to t square into u of t. Try this. H of t is t square into u of t, and you try this also as homework. You can take h of n is equal to 1 by 3 summation k is equal to 0 to 2 into delta n minus k. You try these two now. So this directly you can do t square into u of t because it's starting from 0 and it will go up to infinity. So if t is less than 0, h of t will be s of t will be equal to 0. If t is greater than 0, you put this and solve it. Okay, for this one, h of n is equal to 1 by 3 summation k is equal to 0 to 2. Try to put the values of n here. So you get 1 by 3 into delta n if n k is equal to 0 plus delta n minus 1 if k is equal to 1 plus delta n minus 2 if k is equal to 2. So this is your h of n. Try to plot this. So how will you plot this? You have 1 by 3 into delta. So the signal is existing at n is equal to 0, 1 and 2. So 1, 2 and 3. So 0, 1 and 2 with amplitude 1 by 3 for all three. Similar to that previous problem, you solve this. Okay. So at n less than 0, S of n is 0. At n is equal to 0, S of n is 1 by 3. At n is equal to 1, S of n is 1 by 3 plus 1 by 3. At n greater than or equal to 2, S of n is 1 by 3 plus 1 by 3 plus 1 by 3. You get 1. Okay, you solve these two. Meanwhile, you can write your name and USN in the chat box. You try these problems, okay? It is easy, you try it. Write your name and USN in the chat box for attendance purpose. Is it clear, everyone? Step response. They are simple problems, but you have to do carefully. Did you follow, everyone?
Excuse me, ma'am.
Yes, Rakshita.
Ma'am, for the fourth question, ma'am,
Which one?
you said that it is n greater than or equal to 1, right, ma'am?
This one, this question. Yeah.
Yes, ma'am.
Yeah.
If you are considering that n is greater than or equal to 1, just it should be 1, right, ma'am? S of n
Yes,
should be
ma'am.
1.
Should be 1, ma'am. Later on, if we sum that
Wait.
0 instant and 1 instant, it should be 2, ma'am.
So for n greater than or equal to 1, you are considering from minus infinity to 1, right? Okay, summation will be from minus infinity to n. Previous values also you have to sum, right?
Yes, ma'am. But for third condition, it is only n greater than or equal to 1, no, ma'am.
See.
And that we not consider.
So for n greater than or equal to 1, it is here, upper limit. S of n will be equal to summation k is equal to minus infinity to 1. Okay. This would be summation n is equal to, sorry, k is equal to minus infinity to 1. From here to here, what is the summation? Got it?
Okay, ma'am.
So from summation k is equal to minus infinity to 0. Minus infinity to 0 only one sample. Minus infinity to 1 is 2 samples. So 2. Okay. Substitute it in this formula. Do you check these problems? Any is it clarified? Any other doubts? Okay, guys. Then we can end this session. It's time for your next class. If you have written your name and USN, we can wind up this session. Thank you, students.
Thank you, ma'am.
Yeah.
Ma'am,
Yes.
classification of system, we have invertible and non-invertible, ma'am.
1 minute. Invertible. Yes, you have to know what is invertible, non-invertible.
Yes, ma'am. During finding that, we have to find that inverse system, ma'am. If that system is satisfying a invertible condition, no, ma'am. How to find that, ma'am?
1 minute. Yes, come again.
Ma'am, if that system satisfies a invertible condition, no, ma'am.
Mm-hmm.
We have to find the inverse system, no, ma'am. That is x of t.
It is there. I will check that. Okay, if it is there, I will solve problems, but you have to know about that.
Yes, ma'am. We know that if the system is one-to-one mapping, then it is invertible, like that, ma'am.
Yes, yes. And if you can find the inverse of the system also, it will be invertible.
Yes, ma'am. That how to find that inverse of the system, ma'am?
Just inverse that. You will get it. It is there in textbook. You can just check that.
Okay, ma'am.
Okay. If that problems are there on invertible system, I will solve it. Else you just know what is invertible system. That is enough. Okay.
Okay, ma'am.
I'll explain that next class.
Okay, ma'am. Thank you.
Yeah.